Wildfires are prevalent. We know that they can start from natural causes, such as lightning. We also know that most of the time, they're caused by humans. But how do we know this? How do we figure out how a wildfire begins when it seems like any evidence will be burned? Like detectives, fire investigators can actually use numerous clues that lead them to the origin of a wildfire. A few visual clues include the V pattern wildfires tend to follow, the location of tree damage, deposits of white ash, and the direction of fallen tree and grass stalks. Wildfires spread in a V-shaped pattern. Since fires tend to spread outward, the base of the V pattern formed from burned trees may be the point of origin. Damage to trees will be greater on the side from which the fire approached. Deposits of white ash may be a sign of where the fire came from. And stalks that have fallen forward as fires move over them show the direction the fire is moving. None of these clues are absolute indicators. Factors like wind direction and slope of the land will affect the accuracy of these clues. Investigators also rely on witnesses, asking locals anything they remember about the start of the fire. Taken together, these pieces of evidence can lead investigators to pinpoint an exact cause. One example case is the Hayman Fire, one of Colorado's worst fires that burned over 100,000 acres back in 2002. Investigators followed the evidence and found the cause: 3 matches. These are the forensics that tell us how fires start, but how do scientists help prevent fires, or at least mitigate them when they do occur? Scientists can provide data and tools to decision makers during an emergency management situation. Scientists can gather data on wildfires by working in the field and using instruments like drones, radar, and satellites from space. They gather information like temperature, smoke amount and composition, the number of type of trees burned, and the shape and density of smoke to study plume formation and evolution. All this data can be used to improve computer models that simulate fires and help forecast the extent or danger of a fire. Scientists also determine danger to humans by measuring air quality in areas around the fire. They use a measure called the Air Quality Index, or AQI. The AQI measures pollutants like ground-level ozone and harmful airborne particles. Wildfires cause a rise in harmful particles in the air. We can gain information about these pollutants through satellites, such as the Joint Polar Satellite System, or JPSS, which is run by the National Oceanic and Atmospheric Administration, or NOAA, and NASA. Air monitors can be placed in the location of a fire. With lightweight sensors, these air monitors can even be flown on balloons near the fire. Like any scientific endeavor, there are limitations. For example, we don't know all the chemical reactions that take place as a result of fires burning different types of fuel. We also don't know how a wildfire transitions from a ground-based fire to fire at the top of trees, which is also known as a crown fire. Nevertheless, more knowledge about wildfires helps with controlling the fire as quickly as possible while also keeping people safe. Such decisions include where to send first responders while keeping them safe, when to evacuate towns, and when to shift from a ground-based intervention to an air-based intervention. A ground-based intervention involves first responders directly attacking the flames with water hoses and fire trucks, along with making boundaries around the fire. An air-based intervention is when a wildfire is too intense to handle on the ground. First responders attack the flames using an aircraft carrying fire retardant and water. They also burn down vegetation ahead of the flames to get rid of the wildfire's fuel. Advances in collecting wildfire data, modeling fire behavior, and working with emergency management decision makers will help keep people and the environment safe.